polynomial functions are functions that are in this form. P of x equals a, with an n underneath, we say a sub n. Do you know what that means? The n is just a number, so it means like the first a. This is the next a, the next a. So it's a sub n minus 1, a sub n minus 2. So it just means there could be a whole bunch of numbers, and then a bunch of x's with different powers. So this is x to the power of n. So if that's a 5, then this one is n minus 1. That's a 4, 3, and all the way down to a constant term at the end. So an example would be something like, let's see, P of x equals, pick a number for that a sub n. What number do you want to use? 9. X to the power of 3. It could just be that. That's a polynomial function. It doesn't need to have a whole bunch of terms. It has to have at least one term. We could put another one in there. Plus 2x. So x to the power of 1. Or we could have an x to the power of 2 in there. And then we could have an x to the power of 1. And you can have a constant term. But I don't need all of those terms. Any one of those terms would make a polynomial function. Or all of them together makes a polynomial function. So we're actually going to look at these ones down here and determine which ones do you think are polynomial functions and which ones are not. So starting with number 1 here, x to the power of 5 plus 3. Polynomial function, so you can give me a thumbs up for a yes and a thumbs down for a no. Most of you look like you're saying yes. Yeah, that's a polynomial function. It has an x with an exponent. If you don't see the exponent, that's okay, it's just a 1. And it has a constant term. If it has any combinations of variables with coefficients and exponents and constant terms, then it is a polynomial. But, well, we'll see as we go along, that n, so that exponent has to be a whole number. So the next one, number 2, 5 to the power of x plus 3. Yes or no? Or, I don't know. Okay, I see a lot of no's, and those of you that are saying no are right. The exponent has to be a number, and the base has to be a variable. This one has the base is a number, and the exponent is a variable. The third one is just a 3. Yes or no? So we'll say that one's a yes. It's just the constant term. If it had an x, it's an x to the power of 0, which is just a 1, so you don't see it. Now I'm going to give you a couple minutes to look at the rest of them. Hopefully you can see them. If you need to come up closer and have a look, you can do that. But I want you to decide which ones are polynomial and which ones are not. So what did you decide about this one? 4x squared minus 5x to the power of 1/2 minus 1. No, and why not? Yeah, I just said it really quickly before, but that exponent, the n's and the n minus 1, and n has to be a whole number. So it can't have a fraction or a decimal as an exponent, so that one's a no. How about...
Oh, wait, what? A no?
The next one, number 5, it says x squared plus 1/3 x minus 4. Is that a polynomial or not?
Yes.
Yes. It's okay to have the fraction as the coefficient, you just can't have it as the exponent. This number 6, do you know how to say that? Absolute value of x. Right, and is that a polynomial? No. I'm trying to remember when you learn about absolute values. Is it in this class? Or is it in grade 11?
Grade 11.
Grade 11? Okay.
Oh, I remembered it. No.
That one's a no because of the square root. This square root is actually the same as as a power of 1/2, right? So it's just like the one above it. X, square root of x, or x to the power of 1/2. Number 8?
Yes.
Yeah, that one's fine.
9. Not too sure.
And number 9?
Yeah. Yes. Or
No.
no.
Because the variable is in the denominator of a fraction. Variable can't be in the denominator of a fraction. So that's just a quick kind of look at what a polynomial is. So we're going to be dealing with those type of functions that have a yes. The other thing is we're going to talk about this stuff up here, and we're just going to have a bit more vocabulary to talk about. So the other part that we have up here in the corner is 3 different polynomial functions, and we need to figure out what the leading coefficient is, what the degree is, and what the constant term is. So leading coefficient, if you know what coefficient is, do you know what coefficient is? It's the number in front of the variable. And the leading coefficient, well, that means the first one. It actually means the one in front of, it's the first one if you put it in the correct order, which is descending power of the variable. So if x cubed is the biggest power of x, then it should come first. And if it's in that order, then the leading coefficient is the number in the very front. So in the first one, what would you say is the leading coefficient? 3. And how about in the second one? 1. And in the last one? It's actually 5, because that's the first term. It's also the last term, but it's the first term, so it's 5. So 3, then 1, and 5. Who remembers what degree means when you're talking about polynomials? The degree of a polynomial is the highest power of the variable. So if you have, like this example that we did, it had an x cubed, an x squared, and an x. The highest power of the variable is 3. So this one has a degree of 3. So if we look at that first example, 3x minus 2, what's the degree? 1, right, because it's x to the power of 1. For the second one, y equals x cubed plus 2x squared minus x minus 1. It's 3. And for the third one, I heard somebody say it, 0. And then the last thing is the constant term. The constant term is this a sub 0. It's the term that doesn't have a variable part. So what is it in the first one? -2, good. I thought some of you were going to say 2. But you got the negative in there. -2. And then the second one? -1. And in the last one? 5.